Hi, it's Moser with a quick tutorial on the atom and its parts. So after watching this video, you should be able to identify the three major subatomic particles as well as their locations, correctly describe the charge and mass of each subatomic particle, and use information from the periodic table to determine the number of protons and electrons in any element. Maybe neutrons too. That'd be good. So here's the part you probably already know. The atom has three basic subatomic particles. We could get into the finer details, but that's not really what we're going to do in chemistry. At this level, we talk about the protons, neutrons, and electrons. And you should understand that both protons and neutrons are contained in the nucleus of the atom. You should know that from your research. Electrons live outside the nucleus. And that's about all we're going to say about them for the moment. We'll talk more about specifics later. So let's talk about the nucleus. Protons have a positive charge. Being pro something means you're positive about it. And neutrons are neutral. They have no electrical charge. Protons have a mass of 1.63673 times 10 to the negative 27th grams. And neutrons have a mass of 1.675 times 10 to the negative 27th grams. Those are some pretty small masses. So protons in the nucleus aren't repelled by other protons. You would think they would be. Typically, when we have two things with the same charge, they push away from one another. They're repelled. But within the nucleus, there exists something that we call nuclear forces. And they cause the protons in the nucleus to actually be attracted and held together. There are limits, but the nucleus of atoms up to a certain point is generally stable. Atoms are tiny. They're measured in picometers. And the radius of the nucleus is just 1.0 times 10 to the negative third picometers. A picometer being 10 to the 1 times 10 to the negative 12th meters. We're talking about something that's 1 times 10 to the negative 15th meters across. It's pretty darn tiny. So let's get back to this idea. Let's look at the mass of these particles. So did you notice they're pretty similar? Well, if we wrote those numbers out, they'd look like this. 0.000, oh good heavens, don't count my zeros. I'm not sure I counted them correctly myself. Point a whole bunch of zeros, 1.673 grams, versus point a whole bunch of zeros, 0.1675 grams. Really? When you get right down to it, that's almost no difference whatsoever. You couldn't tell the amount of difference in the mass of these two particles without some pretty sophisticated equipment. So what chemists have done over the years is to decide that they will generalize the mass of the proton. So we say that one proton has a mass of 1 atomic mass unit, abbreviated AMU. We also say that one neutron has a mass of 1 AMU, 1 atomic mass unit. Well, that makes life a little bit easier, and it certainly makes the math a little bit easier. This sort of general fudging works quite well, and we'll explore it a little further. Because of the fact that the atomic mass is equal to the atomic mass of one proton is equal to 1 AMU, and the atomic mass of a neutron is equal to 1 AMU, the atomic mass ends up just equaling the total number of protons plus the total number of neutrons. It's measured in atomic mass units. And this is a fudge. I'm admitting it. Because the masses of protons and neutrons aren't exactly equal, but we still assign them this mass of 1 AMU. Let's practice then finding the number of protons in a substance. Actually, back that up. We're going to practice finding the number of protons in an element. We're also going to look at their relative charges and figure out how many electrons are in a single atom of an element. Neutrons, that's going to take us just another moment. So we're going to start off with some very basic math. Positive 1 plus negative 1 equals what? 0. Right. Positive 2 plus negative 2 equals what? 0. Fantastic. So what you know is that you have equal numbers of positive and negative charges. The overall charge is 0. So for an atom that has 3 protons, if it also has 3 electrons, its overall charge equals 0, because the positive charges and the negative charges cancel one another out. That means anytime that we are looking at a neutral atom, that is an atom with no charge, we know that the number of protons and electrons in that atom must be equal. So now let's practice finding the number of protons and electrons in a few atoms. Well, I guess first we have to know a few things about the periodic table. Hi, this is the periodic table. Nice to meet you. The periodic table's got a lot of information packed into it, and we're going to start here with beryllium. Inside every square, you'll find an abbreviation, which is the atomic symbol. These are standardized, and there is only one correct atomic symbol per element. Then you'll find a number above the atomic symbol. It's a whole number, and you'll notice that these go in order as we move across the periodic table. That'll become really important in the next chapter. So this is the atomic number, and the atomic number is equal to the number of protons in any atom of this element. This atomic number is the identifying number for this element. It can't ever change. If we change the number of protons, we actually change the element. Elements are identified by the number of protons they had. Everything else is changeable. So any atom of beryllium anywhere in this universe or any other universe we could ever find is going to have how many protons? 4! That's right. So if we're talking about a neutral atom of beryllium, and we know that a neutral atom of beryllium has 4 protons, how many electrons must it have? If it's neutral, it has a 0 charge. Well, it's got to have 4 electrons as well. That's really ridiculously easy. How many protons are there in any atom of iron? Hit pause. 26! Yay! Because the atomic number is 26. How many electrons are there in any neutral atom of iron? Go ahead and hit pause. 26! You got it. Good. Now, what if we take out one step in that discussion and say, looking at a neutral atom of barium, how many electrons would it have? It's a 2-step process, but I'm not asking you the first part. You know the atomic number is 56, therefore it has to have 56 protons. If it's a neutral atom of barium starts off with 56 electrons. Okay, you good with that? Now let's talk a little bit about mass. We're not going to talk yet about atomic masses in all their detail, but we're going to talk about them in very generic terms. When we are given a mass for an element, say an atom of carbon, and we're told that this atom of carbon has a particular mass, 12 AMUs, could we figure out how many neutrons are in the atom? We could. First, we have to know a few things. The mass of any atom is equal to the number of protons found in the atom plus the number of neutrons found in the atom. So, let's rearrange this, because what we want to do is solve for number of neutrons, and this is really just a very simple algebra problem. Okay, therefore, atomic mass minus number of protons will give us the number of neutrons. Well, let's look at the atomic. How do we find the number of protons in an element? That's right, the atomic number. So we were told that the atomic mass is 12 AMUs. We're told that there are 6 protons in an atom of carbon. So how many neutrons are there? 6. And a quick word about treating this as algebra. Because if we say 12 AMUs minus 6 atoms of carbon, that doesn't make any sense. But what we're really saying is 12 AMUs total mass minus 6 AMUs from protons, which tells us then that the other 6 AMUs of mass must be being contributed from the neutrons. So it tells us the number of neutrons. Let's do one more, and then you can go off and practice. Let's say we have an atom of cobalt with a mass of 59 AMUs. Well, how would we find the number of neutrons? We know that this cobalt atom has a mass of 59 AMUs, and we know that 27 AMUs of that mass is being contributed by protons. So the remainder of the mass must be from the neutrons in the atom, which means that 32 AMUs of the mass are from the neutrons. Since each neutron weighs 1 AMU, we have 32 neutrons. That was easy. Okay, off with you.